Incredibly, Proxima b is only 4.2 light-years away from Earth. Yet, even at this seemingly close distance, the thought of ever reaching this exoplanet remains an enormous challenge. This distant world, orbiting the star Proxima Centauri, isn't just the closest exoplanet to Earth, it's also thought to potentially be habitable. However, given that we haven't even fully explored the planets within our own solar system, interstellar travel feels like an unachievable dream. But what if that could change? Scientists today are deeply invested in developing advanced propulsion systems that could one day bring Proxima b and other exoplanets within reach. But what revolutionary concepts are currently in development? How feasible are they, and could Proxima b realistically be the first exoplanet we set foot on? Join us as we explore what it might take for humanity to journey across the stars. If there's anyone, or rather, anything, that knows how to journey through space, it's the Voyager probes. Voyager 1 and Voyager 2 have each traveled distances that seem almost unimaginable. Together, these probes have ventured over 20 billion kilometers from the Sun, which, even at such distances, still only represents a fraction of a light-year. In fact, they've barely reached what we'd consider the edge of our solar system. To put things in perspective, Proxima b lies around 4.2 light-years away. That means that even the impressive Voyagers, moving at roughly 61,000 kilometers per hour, would take around 70,000 years to reach Proxima b. And keep in mind, these probes aren't moving at a leisurely pace, they're among the fastest man-made objects ever created. But they're not the fastest. That title belongs to the Parker Solar Probe, which was launched in 2018 and recently hit speeds over 635,000 kilometers per hour. Despite this mind-boggling velocity, the Parker Solar Probe would still need several millennia to reach the Proxima Centauri system. Proxima Centauri, a red dwarf in the Centaurus constellation, is part of a triple-star system that also includes Alpha Centauri A and Alpha Centauri B. Proxima b, discovered in 2016, orbits this red dwarf within its habitable zone. It's not surprising that this rocky planet has attracted so much attention. It's not only close to Earth but also has some interesting Earth-like characteristics. On the Earth Similarity Index, a measure of how much an exoplanet resembles Earth, Proxima b scores 0.87. The habitable zone is a range of distances from a star where conditions might allow liquid water to exist on a planet's surface. However, this doesn't automatically make Proxima b an Earth 2.0. Let's dive into the details. Proxima b is about 1.17 times the mass of Earth, which places it in the category of Earth-like exoplanets. Yet, that term Earth-like can be misleading. It refers only to the fact that Proxima b has a rocky surface, not that it's necessarily habitable. Earth completes its orbit around the Sun in 365 days, but Proxima b orbits its star in just over 11 days. That's because it orbits very close to Proxima Centauri, at a distance of only 7 million kilometers. Due to its proximity to its star, Proxima b is likely tidally locked, meaning one side of the planet always faces Proxima Centauri, while the other side remains in perpetual darkness. This would create a hot day side, a freezing night side, and a narrow twilight zone between the two extremes. If life were to exist, it would likely be found in this narrow, temperate zone, where temperatures are relatively stable. For life as we know it, water is essential. And simulations suggest that under certain orbital conditions and with a suitable atmosphere, Proxima b might have a substantial amount of liquid water in this twilight zone. But keep in mind that this is still a theoretical model. Many of the factors that would allow for liquid water have not been directly confirmed. One significant obstacle to habitability on Proxima b is radiation. Proxima Centauri is a red dwarf with only about 12% of the Sun's mass, yet it's far more volatile. Researchers observed a powerful radiation burst from Proxima Centauri, which increased the star's ultraviolet radiation output by 14,000 times in just a few seconds, an intensity far beyond any solar flare recorded from our Sun. Red dwarfs like Proxima Centauri not only produce more intense radiation but also have frequent outbursts. These radiation events pose a serious threat to any potential atmosphere on Proxima b. However, there is a possibility that Proxima b might still have a fighting chance. If it has a molten core, it could generate a magnetic field strong enough to shield it from some of Proxima Centauri's radiation. One theory even suggests that Proxima b may have originally formed farther away from its star and was later captured into its current orbit. This could mean that it once held a much larger reserve of water. Simulations indicate that Proxima b might have once had up to 10 times more water than Earth. Even if it lost 90% of this water, there could still be enough left today to support life, particularly in the twilight zone where liquid water might still exist. Given that the Voyager probes would take tens of thousands of years to reach Proxima Centauri, it's clear that our current propulsion technology isn't up to the task. Enter Breakthrough Starshot, an ambitious initiative funded by billionaire Yuri Milner and supported by renowned scientists like the late Stephen Hawking. Launched in 2016, Breakthrough Starshot aims to send nano-sized probes to Proxima Centauri within 20 years. But how would they achieve this? The concept involves launching tiny spacecraft equipped with light sails, which would be powered by a powerful laser array on Earth. This laser would push the light sails, accelerating the probes to speeds of up to 20% of the speed of light. Such speeds would allow the probes to reach Proxima Centauri in just over 20 years. This plan, though incredibly ambitious, isn't as far-fetched as it might sound. In fact, the concept of using light sails has been around since the 1970s, first proposed by physicist Robert Forward. While promising, Breakthrough Starshot faces several challenges. To reach the target speed of 60,000 km per second, the probes would need to be incredibly lightweight, likely no larger than a microchip. Each would carry a small computer, a camera, a transmitter, and a solar sail. The Earth-based laser array, a crucial component of the plan, would consist of numerous lasers working together to create a 100 gigawatt beam. This beam would be directed at the probe's solar sail, accelerating it to 20% of the speed of light in a matter of minutes. But what happens when the probe reaches its destination? Decelerating upon arrival at Proxima Centauri is another major challenge. One proposed solution is to use the light from the star system itself to slow the probe. By flipping its sail around, the probe could use starlight and the gravitational pull of the stars to gradually decelerate, allowing it to stay within the system for observations. However, this would increase the total travel time to around 100 years, or even 140 years if the probe is to reach Proxima b specifically. Even with its immense technical challenges, Breakthrough Starshot represents a realistic possibility of reaching another star within a human lifetime. The project's scientists estimate that it will take 20 years to develop the necessary technology, but on paper, the mission is achievable. One day, we may indeed witness humanity's first interstellar exploration as we attempt to understand and even visit distant exoplanets. If you're fascinated by the potential of interstellar travel and eager to follow humanity's journey toward the stars, make sure to hit that subscribe button. Don't forget to give us a thumbs up and share your thoughts in the comments below. Could Proxima b really become humanity's next home, or is it just a dream? Thank you for joining us in exploring the universe. See you in the next